gonna be reasonably casual, so that's right. Right, hello. Wrote this literally an hour ago. I'm used to giving presentations, but not so much interesting ones. So I decided not to talk about research. I'm talking about something that I do in my free time occasionally. And I'm specifically going to be talking about pedagogical improvements to programming education in pre-university students, or more specifically, how to make programming less boring for children. And yeah, how to make it sort of more interesting stuff as well. So just to give those of you who don't have that much perceptual understanding of like the evolution of programming as a discipline, it started in 1837, excuse me, with the boringest sounding machine in the world called the analytical machine. That thing there, which is designed to solve simple things like polynomial equations and things into tables that minimise human error from creating them sort of manually. First program in the world was the one who designed theoretical computers, programs for that theoretical computer. I don't think it actually came into existence until about 80 or 90 years later, but yeah, when the first sort of computers actually came into existence and the job programmer became a real thing, well usually it was more of like an electrical engineer or as a mathematician, it looked a bit like that. If you were lucky enough to work on one of the 5 computers in the world, you were probably just rearranging cables and wires to try to get some sort of output like the trajectory of an artillery bombing or like the number of things that you solve near. So some very, very simplistic, very, very basic problems designed to solve for very standard sort of systems. I think in 1950, the founder of IBM famously was misquoted as saying that he saw a world market for maybe 5 computers in the world. So at that time it was pretty small and still very specialist, very, very much the domain of physicists and mathematicians were the people who were sort of doing this sort of work. That sort of came to change about 30 or 40 years later when microcomputers came into existence. Started off sort of being small computers like this one that weren't particularly well known of to ones like this, which actually made it more of a consumer item. So laymen actually not only had the reason to sort of like learn how to use computers, but there was actually work for them as well, and they could get jobs either in using office computer systems or in the very, very sort of fledgling other industries of IT that was coming to existence at that point. When office computers became a bit more common, started to sort of supplant jobs like secretaries and things, then we sort of get to the position where we're up to today. So yeah, like it's gone from being very much a job that was specifically controlled, or was specifically being employed either if you're a mathematician or a physicist or an engineer, and usually sort of quite a specialist one at that, usually quite an echelon thing, to being something that most people will encounter in their daily lives and having sort of some experience with as well. So it's really important that when we think about teaching it as a discipline, we stop treating it as though it's something that, you know, the top echelon of people used to do back in 1870, and it's something that, like, you know, children and things can do today. This is a quote from W. Dijkstra. I think I got his name wrong, that's right. But yeah, he famously said that programming is one of the most difficult branches of applied mathematics. The poorer mathematicians had better remain pure mathematicians, which is this elitist attitude that still sort of dominates the field today, and in my opinion really shouldn't. We need to sort of step away from this idea that it's a very mathematical sort of idea. It is, certainly, but more to the point where it's no longer unapproachable or ridiculously difficult for most people to sort of get into as well. So I first learned to actually do computer programming at university, and I've always like equated the way I learned to like being taught by Indiana Jones, because Indiana Jones is an awesome guy who does really exciting things, but he always teaches in the absolute boringest way possible. The two things I sort of equate with that, and that's the thing. Like when you work in this sort of field, you're doing exciting, interesting, you know, enjoyable things, but the way that we're still being taught is through like lecture slides. Through live programming experiences where people sort of sit in front of you and they'll just type code, fix their code, and then you sort of follow along and try to understand what they're doing. Or just by giving concepts and things, you know, through workshops, which is not very interactive for other people, and it doesn't really bring across the way that actual programmers tend to work in real life. So in the past couple of years I've been sort of doing this both as a hobby and as for actual like work. I've sort of gone for a more interactive method where you specifically work with someone else trying to solve different problems and have a more communicative sort of function to do that with them as well. So the big thing though, and one of the hardest things that is to try and get people engaged in sort of work is the fact that it's aimed for, you know, people between the ages of maybe, you know, like university levels of education, if you know what I mean. So they're it starts off with something like this. Like you'll learn your first program, it'll be on a black screen, it'll probably be something that sort of looks relatively simple. This is just like a basic program. Can anyone understand that at all? Yes. What is it saying? What's it doing?
it says hi there in an infinite loop.
Yes,
Yeah.
right.
Keeps on saying hi.
It keeps saying hi there over and over again. Yeah, the 10 print hi there just prints out the words hi there, and then 20 goes to 10, which will go back to the line 10 and just keep doing that as long as the program is going, which is to say forever. So it will just keep doing that over and over again. And that's usually the first thing you'll do in an intro to programming. This is a similar-ish program, but written in the Java programming language here as well. Same sort of thing. It has a few little bits of structure and stuff around it, so you have to sort of say hello, world, in that sort of typical way. And this is another program in C++, once again, similar sort of structure, but boring, not very interesting to look at or terribly interesting to sort of like learn about in the first instance. And that's kind of the problem, is that we have this sort of very slow, boring way of learning how to program, when really, you know, it should be a lot more interesting than that. And facing this sort of thing, sort of 6 months or a year down the track, is why we have this sort of this relatively poor sort of level of entrance and stuff into the field. So a bunch of tools exist to try to make it a little bit more exciting and a bit more approachable. I've just got a few of them here to give you an idea. This is going to be really short. I'm firing through this. So this tool here, if you can see it clearly, I'm not sure that you necessarily can, is called Alice. This is designed as a programming tool to try to create 3D scenes or very, very simple games with like a 3D sort of design. So you can still see at the top there as well, it's got a thing there. It says, you can't really see it, but it says click 5 zombies to win. You can't quite see that's right. But the thing is that what they've done is they've placed down three-dimensional objects inside that little window, and they've written this very, very simple section of code here that allows the user to interact with that as well. But as opposed to having to type that in, they've just dragged and dropped these little squares along here. They've put those directly into the window as they needed to, so they've sort of assembled it from building blocks to be able to create these sort of constructs here as well. So in that one there, they're just sort of seeing if there's a click, and if the click is touching the zombie, if so, then it's allowing the zombie to be killed. So really sort of basic stuff there as well. Another system that's being used a lot nowadays, I saw a lot of kids using this when I was teaching, is Scratch. Is anyone familiar with Scratch at all? Possibly? No? Yep, okay. That's right. And this is the same sort of concept, so it's using building blocks. You can see there it's created these different like structural features of the language that are being produced, put down into a giant square, and then being used to influence the screen that they've made here, usually out of just pictures that they've either drawn themselves or sort of modified as well. So in this one here, you can say that when there's a click, it's checking the direction, and then it's doing this forever. It's moving the fish by various different steps, turning it in a certain different direction, and allowing it to bounce and things. So it's just sort of giving it some very, very simplistic, very obvious sort of commands that don't require a large amount of work to sort of be able to understand and work with in the first place. So that's a nice tool for that. This one it's harder to show, it's easy to demonstrate, but we'll see. This is called Code Your Game Labs, and this is again also designed to teach things from basic mathematics to, again, creating sort of simple games, usually aimed at sort of primary to high school sort of levels of proficiency of schools. And the idea is that first off, the student will build an environment. So this has been built with like paintbrushes and things to sort of, you know, place out where grass is and where paths are and bridges and that sort of thing. You know, trees and castles and other entities like robots and spaceships and things. And then they actually construct the building blocks of the language by clicking on the thing they want to modify and just telling it what to do in certain circumstances. So in this example here, they've said that when the person, whenever the thing they're looking at sees a tree, it will move forwards. If it bumps into a piece of fruit, then it will do some other action on a different page. And if you press the A button, then the thing has to jump. So really sort of simple, basic commands that allow you to sort of program very simplistic behaviour just through using sort of largest blocks that modify one another on step. That's the only programming language I know of in the world that you can use, you can make using Xbox 360 controller. So that one exists there as well. Which are all ways to try to make this a little bit more useful or engaging to children and at least to younger audiences as well. But the one I'm going to be looking at today specifically is at Minecraft and seeing how you can sort of use Minecraft to be able to perform some really simplistic sort of programs and things as well. So we'll switch over to it now. I'll sort of show you roughly how it works. Okay.
Minecraft!
Yes, Minecraft. Has everyone or anyone played Minecraft? Yes? Cool, at least
I've seen people
I
play
tried
it.
for about 5 seconds, but it makes me dizzy.
makes
I
you dizzy.
played the My Little Pony mod in Minecraft and it was amazing.
I can't play 3D games.
No.
Okay, well I'm sorry, I'll try to make it as least dizzy-inducing as possible.
I'm just not going to look.
Fair enough, that's alright. So yeah, so it's just Minecraft, and the cool thing about Minecraft is it's just it's a perfectly interactive environment, right? You can modify everything in the world and you can get tangible outputs from what you can do just from sort of mucking around, you know, just punching trees at the moment. There's a lot of stuff that you can do here as well, but the cool thing about adding computer programming into this environment is that you're able to do more complex and interesting interactions and things, but also be able to sort of work with computers at the same time. I'll just give you a simple example. So I was showing you how to do Hello World before, and in this system it's quite easy. We just go like that. So you just get a really simple sort of like environment that's quite easy to learn how to program from the very basis. But that's a really boring example. We'll look at a more interesting one. So let's go to a turtle, and let's teach the turtle how to dance. So these little things here have got a few different interactions they can do. They can move forwards, backwards, they can turn left, turn right, and they can go up and down. Those are their various different interactions, and we can teach them to dance. So let's do that now. Alright. So does anyone have any ideas about how it might, using those 6 interactions, going up, down, left, up, down, forwards, backwards, and turning left and right, how you might be able to program a computer to sort of dance?
By making them do the hokey pokey.
The hokey pokey? What's the hokey pokey?
You turn around. That's what it's all about.
You go left, and then you go backwards, and then you go right, and then you go backwards, and then you go in a circle, and then you clap hands.
Hang on a second. Do I have pens?
Yeah.
Surely we have pens.
I'm looking for whiteboard pens.
Yeah, whiteboard
They
pens.
are over there near the chocolate.
Alright.
Most of them don't work.
Oh, alright, we'll try to find one that does.
The pink one usually works.
The pink one.
Yeah.
This one?
No.
Very nice.
Closer to your crotch, to the left.
Alright. So what's this? What do you do?
What?
So you go left, then back, then right, then back.
You go left and then back, and then right and back, and then you spin in a circle.
Left, back, right, back, circle. Right?
Yeah.
Okay, let's do that now, because that sounds like fun. Alright, so how we would do that in this language is you would go, so we just go while true do, like that. So do this forever, is what we're saying there. So we're going to go, dots turn right. Alright, so, that's misspelled. So yeah, so we're going left, forwards, then back, then we're going to turn right, then forwards, then back.
Well, you gotta go right, then back.
Yeah. Just remind myself. Forward, yeah, that's right, okay. Hurry up. There we go. Alright, so what did you say we have to do? So we have to go.
That is what it's
It
meant
is
to
right.
Yeah,
Turn right, but it says.
It says turn right twice because you turned left before.
Ah, right, turn right.
Yes,
forward,
sorry,
back.
I should have
Awesome.
explained that.
My
So yeah,
mistake.
you turn left, forwards, back, turn right again, forwards, backs. Then you spin around in a circle.
There you go to circle, yeah.
Alright. And then we're just going to go turn left, and then we'll just do that 4 times. So
Yep.
4. Don't worry about what that means too much. If I was teaching you more seriously, then I probably would explain it, but not just now. I'm just going to go turtle up, turn right. Okay, and that should hopefully do it, I think. Okay, I forgot to do something. Okay, you die. Sorry, I didn't mean that how I sound. Let me just give him some fuel. He needs petrol. It's my least favourite feature of this mod. Alright. There we go. Alright. Okay. Now, hokey pokey. And off he goes. There you go.
Stick the deck.
And turn around. Oh, you actually, that's amazing.
There you go.
I'll wait a minute.
That took about a minute, and we got something sort of kind of cool out of that as well. So that's sort of like an awesome sort of beginning sort of starting project that you can build much easier. That I would say is a bit more fun than learning how to program Hello World. So we'll try something else that's a bit more practical. Not to say that learning the hokey pokey isn't practical. Let's just go.
Depends on how many kids you're around.
Alright.
First you're surrounded by them.
So we can teach him, why don't we teach him how to build a bridge?
Ooh.
Right? Something that is like a, like a pragmatic thing that actually has sort of like a tangible outcome that we can sort of display. So we can teach him how to build pretty easily. So if we want to build like a bridge, let's just build some arbitrary one across a stretch of water. How we might build it, and the way that we tend to think about this is if you're trying to build a bridge yourself in this game, how would you probably do it? Any ideas?
I have
Do
no
I
idea.
know where I'm
No?
building the bridge to?
God, it was so long.
Or am I
guys.
just...
So we can put down blocks like this, right?
Yep.
So we can pretty much just keep doing this, yeah? Like, at infinitum we can just keep going like, let's make it 3 wide, and we can just keep going like that.
So I'm just going to keep going until I hit land.
Yeah, just sort of keep going. Well, you can, keep going until you hit land or until you run out of wood or whatever you like. But you can see that, like, pretty much what we're just going to do, we're just going to build a bridge. Let's just make it, 3 by however long it tends up to be, and just sort of keep going as long as you can, yeah? Alright, so let's try that. Build bridge. Alright, so we're going to go this thing again. Alright, so we're going to go... So we're going to step him forward first, like that. Then we're going to make him turn left. Then we're going to go step forward 3, roll forward. Till dots turn right, and we'll just do this twice. So what we're doing now is we're going to make him step forward, then he's going to turn left, he's going to walk that way as long as he needs to make the bridge, turn right, forwards, turn right again, and keep going like that, right? So we're going to make like a zigzag to build the bridge in, where did I put that pin pad?
Is there a go-to statement in this
I'm
language?
actually the worst. No, no. Yeah, so he's going to build like this. Okay, you can't see that, but it's there.
We get the...
Yeah.
Yes, it is.
Do it like that. So we'll do it like that, yeah?
It's not a restaurant.
Nope.
See
What is it?
The gas station. In Coffs Harbour.
Question, why is it
It's
called
a
a turtle when it's not a
restaurant.
turtle?
That's a really good question that I actually can answer. The turtles in this are named after turtles in the language Logo, which was made in 1980, and their only function was they could move around.
Oh, yeah.
That was the entire language.
They look like
Yeah.
turtles on screen, and the robot ones that they made for real world people to have running around the floor are shaped sort of like turtles. If turtles were made out of grey plastic.
There's an example of like an emulation of a turtle there as well. Be able to see that.
Yeah.
There you go. Right, so that's one that's been taught to go forwards 100, left 90, and then forwards 100. So yeah, so that's pretty much what they're named after, is that sort of construct. We'll just finish this quickly, and then move to something more interesting. I reckon that's going to work. I might have not done it very well. And then what we're going to do is just going to go like that, wherever he has to move forwards. Alright.
How does it know what to close down?
That's a good question. Also, but like I said, we won't get that deep because I'm just showing you quickly. This little box here, he's got like a little, you can see that tiny little grey frame around that, you probably can't on the screen, but that can be moved around, that's the selection box. You can just choose what icon, so you can have different materials and everything, you can make that of wood and all sorts of things. It's entirely up to you really.
So can turtles make more turtles?
Yes. yeah, that was the thing, is to try to make infinite turtles.
Have you
Okay.
built a turtle factory before?
Yeah, it's difficult, but it's
How
fun.
many
Is
turtles
there
did you
any
end
chance
up
of the
with?
turtle
Infinite
languages
turtles.
spilling out of the Minecraft world into the real world?
No.
I know theoretically infinite, but how many did you actually have?
Oh, I don't.
Oh wait, it's gone.
It's going.
It's escaping.
Yes. And I think it might actually be working. It's not 3, it's 4, but that's okay. Close enough.
Levitates.
Yes, it levitates, it flies. They can't be used as transportation, unfortunately. I did try that. But yeah, and so he's just going to keep going until he runs out of wood or petrol or both, until he's done. So yeah, that builds a sort of a practical, feasible thing that you would sort of possibly build yourself in Minecraft, but in a more engaging way. So the reason this is kind of like, this is attractive as a teaching medium is because this is the sort of thing that kids are doing in their free time anyway. So finding a way to not only make that either easier or more interesting for them as well, like integrating sort of computer science education at the same time, is that sort of makes it a bit more interesting for them and a bit more sort of exciting in that sort of regard. Which is why we kind of really sort of latched onto this as being a sort of an interesting way of showing them how to sort of play around and programming things. And because this is such a tangible world, they can dig as well, so they can make caves, or they can make buildings and things. I programmed a thing where you give them a picture and they draw it with materials and stuff, which is quite good. I might show you that a bit later, but as I said, we'll see how we go. So yeah, that's kind of what I was looking at was actually trying to find some way to be able to integrate this sort of technology as a means of teaching primary and secondary school students. So I'm just going to go through a few of my ideas. The first one I came up with was this thing. I'll keep the sound off because it's a bit strange. But effectively what I did was I rounded up about 20 randoms from the internet who were interested in learning a bit more about programming. I gave them sort of 4 or 5 different tasks, I taught them how to do it, and then I sort of set them about doing it. So this one I got them to try to use those sort of build like a little castle in those red rings you'll see around there. Some did better than others, but they all sort of got somewhere, which was sort of really quite cool. Yeah, he got a number wrong, so it was going too far in the wrong direction. So yeah, we got like this we got like a very, very varied set of people who all sort of had their own sort of way of solving the problem, which is really cool. Which sort of had like a sort of very fun outcomes. That was quite good. One of the other tasks we gave them was this one. So I wanted to find a way to make programming a bit like a game. So I put them in teams, in 2 separate teams, and I gave them TNT and turtles, and their goal was to try to blow each other up in different castles and things.
Nice.
Yeah, that was sort of a simple idea. I thought would be a fun sort of way for them to graduate. They kept blowing me up, but that was okay. So they'll not only they were trying to implement those sort of practices in a competitive and sort of enjoyable way. So we got kind of, yeah, that was pretty good. So they got to sort of muck around. A lot of things went wrong with that as well. As you can see, they sort of dug a lot of holes and they went missing and things. It got a bit ridiculous after a while, but that was a pretty good outcome. Like that was quite a fun sort of project. That went really well. So that actually got a little bit of attention. I was contacted by a few universities after making that one go live, and they were curious about me sort of extending the idea. So I ran that 3 or 4 more times after that as well. We had to sort of run it in time zones appropriate to other people, so that I had to run this between I think about 3 o'clock and 6 o'clock in the morning, which wasn't much fun, and it was a very, very long sort of late night experience. But that's okay. It was still quite good. I refined that previously and sort of turned it into a proper formalised game, which I sort of show here a bit. And this is an example where effectively I had some people who I'd met through this physically organise a proper sort of environment, and then we tried to run this more competitively and see if we can get some people sort of doing this more regularly sort of thing. So we gave them a bunch of supplies, a bunch of TNT, and then their goal was just, as I said beforehand, try to destroy as much as possible with what they had. So like, I think here I demonstrate a very simple algorithm for how to like destroy the other ship, I think in this case. I think. It's been a while, I'm sorry, this is very short term, but that's right. So yeah, you can see that similar sort of code to what I was writing beforehand, just sort of moving forwards regularly, finding a situation when they can drop it, then it just blows up the bomb. So.
Do you get to watch it do it?
Yes.
Yeah.
Yeah, there was a lot of. This is quite an intense game.
That looks like he's gonna die.
Yeah, that guy. Yeah, because if you lose a computer, then you lose the code. So I was trying to furiously save it. Didn't manage in the end, but that's all right. Oh yeah, that was quite good.
Wait, there's no save on this?
No, you must keep it on a disk on your own person, so it's quite difficult. That was one where I got them all to go at once. That was really cool. They're communicating via network, which is quite good. But yeah, so there's quite a lot of like room for variation. You know, so there's a lot that you can sort of do with this to make it a bit more interesting. So it was a fun game. I quite enjoyed that one. I worked with a few different people on that, which is really nice as well. So yeah. I didn't talk much about the motivation about why I'm doing this in the first place. So I mentioned before that like the reason I was sort of looking at these different methods is because I find programming as it's currently taught to be quite boring. The other thing I don't like about it is that it's a very, at the moment, it's a very insular sort of community. So we have a very serious gender divide in computer science graduates. It's one of the very few disciplines of science that has not balanced out in terms of the people that are enrolling. I think in ANU it's still about 5% are females, opposed to 95% being male, which is a bit ridiculous.
A bit higher than that.
It's a bit higher than that. Has it gotten better since?
Yeah,
I think it was 2012.
graduates,
What up to now?
something like 10 to 15%.
Yeah, that's it. University of Cape Town's about 15. I think Flinders is
Yeah.
about 10%. Yeah. So it's in that range, right? It's not like 35 or 40 or even 50%. It's well below that level. And that's not just like the math. There's a lot of different demographics that are being missed out. It's still a very insular community, which is unfortunate. So yeah, I was hoping that this would be another way, because if we're engaging people at a younger age in a much more sort of gender neutral environment, hopefully it would be more appealing at those ages to help people sort of be more enticed to look at science and engineering degrees in university. So that was one of the intended outcomes. We worked with a few other projects that already exist in that sort of space, like Digital Divas and a few others. So yeah, that was one of the other sort of motivations that we had to try to make this one work as well. So yeah, that was the other things that we did. So after we did that a couple of times, we sort of thought, well, this is going quite well. We have quite a lot of people sort of applying, so we tried to make a more formalised server. So the way that we did this was we created this thing called the Computer Craft University. This is myself and a few other members of this community, as well as one or two lecturers, which I've discovered recently were using my work without my permission, but that's okay. Anyway, so we built this server effectively, and the idea was that we would have various different people who knew different pieces about code, and then people could just log on whenever they wanted to ask questions, and we'd try to answer them as best as we could. I also ran a few different exercises for people to run, to hopefully practice their skills and get a little bit more interested in things, and I tried to find sort of interesting problems for people to solve in sort of the world of Minecraft. So this is like a maze that I produced. This is one example. So what you would do is you put your turtle, I think it was on that square there, and every single block of wool that was coloured corresponded to a different command. So if the block was red, they had to turn right, I think. If the block was yellow, they had to go forwards, then down. If the block was orange, they had to move forwards. And it was sort of giving them sort of simplistic commands that they would hopefully use to sort of like create a more, to be able to sort of solve these sort of mazes and things. And we liked this because not only did we have like an interesting environment for them to sort of play around with, it was also a fun, they could modify it and create their own sort of mazes as well. So that was one of the things we were working on. This was another example. We would have them place a turtle sort of there-ish, and then these pistons you can see are activated by this red wire that runs around the place, so they have to sort of move their turtle and turn the wires on and off to get from one side to the other. So it was sort of about logic gates and about sort of trying to manipulate sort of basic sort of movements and things, which is quite nice. That was another one of the mazes. I don't remember what that one was about. I think it just had to go on a loop or something. I don't remember. And then yeah, as I mentioned beforehand, the thing at the end where they blow each other up, which was always very well received. Sorry?
I said, yay, destruction.
Yes, exactly. Turns out that having an educational server online is a terrible idea. Don't do it. And I'll explain to you why. So the first problem that we found was that we had to have other teachers. So like there were maybe sort of 3 or 4 of us. It wasn't really enough for the students. So we tried to get a few others, but the thing is that, like I say, we all had different time zones, and so did the students. So I had a lot of very, very late, very sleepless nights trying to communicate with people in like Germany and America that I just didn't really have time to. And because most of them were either in primary or secondary school as well, it meant that I could only see them after school hours, which was usually something absurd for me. So it was very difficult, very challenging work, but also presenting material like on top of previous life was just too much effort for everyone to sort of eventually collapse into itself. So it was a terrible idea, and I don't recommend doing that at all. But that idea of having like an engaging space for people to work in was actually much more successful than we thought it was, which is really cool. One other thing that I can't show you on this computer because it's not on there, but I'll talk about anyway, was one of the other things that we were hoping that this could benefit. So I talked about finding engaging ways to teach programmers being useful for like analytical skills, mathematics, and also for trying to engage people in computer science. And one other idea that's been explored a little bit in the literature, but not so much, is the idea that it also improves literacy. Linguistics and computer science are very closely tied together because it's a formalised language structure, and we were wondering if, by trying to teach that to younger audiences, it actually improved literacy skills or English skills as well. So we ran one last smallish trial at a primary school in Tasmania, which has the lowest literacy rate in Australia, from my understanding, or near to, and we just took them through writing, in this case, Python code, simplistic Python to see if that would actually sort of improve their understanding about how standard sort of linguistic structures and things worked. We didn't find a lot of evidence of that. It's just an interesting anecdote I thought I'd mention because I'm almost out of time now, things to say. But what all of this is about, like I said, this is just something I do for a bit of fun, but it's all sort of driving towards that idea about what our final, the way that we should really be teaching computer science and what the future of computer science education is in universities as well as in primary and secondary schools. And it's a question I invite you to think a bit more about later. But that will do it for me. So thanks for listening, and if you have any questions, do feel free to ask.
Can the turtles see
Yes.
things other than things that are directly around them?
You
Oh my god,
stop.
it's still going!
You can stop. Go on. No.
No, keep going.
Oh, he's out of wood. There we go.
Fly.
He's done. Alright, hang on a second. They can sense one block in front of them, one block behind them, and one block above them. So I think if we go turtle, I think it's...
Is there any way of seeing further than that?
detect up. Yeah, that's it. And go down. So he knows he's on a bridge, but he doesn't know anything about that. There are what you call peripherals that you can attach to the turtles that allow you to cast a line and let you know how far away they are. It's not part of the core thing, but yeah, you can include that functionality. Or code it yourself if you particularly want to as well. That can all be added. Like I say, a lot of features that are missing in this you can just make yourself, which is I guess one of the appeals of the sort of environment in the mod. So when people ask the question, can it do this? Then we can sort of say, if you wanted to, then it can. Yeah.
So there are other peripherals where you could write them, so it could look all around it and see where the closest land is.
Yeah, I'm pretty sure there's like a sonar one or something like that as well. Yeah, that lets you know roughly where a position occurs. I think there's some chunk loaders and things too. It's complex, and I haven't delved deeply into the Minecraft modding community because I don't hate myself that much. But you can, I think, do those sorts of things through the Java backend.
So you could make it so that it works out where to build a bridge.
Yeah, I just made them. I did the scouting myself. But yeah, you could definitely sort of have them being sort of autonomous and things. I had a fun idea for one. I never got around to it. I was going to make like a beehive style structure where you'd have them sort of create their own little hovels and things and request materials and things. They could build their own sort of cities as they went along. But I never quite got around to it. Perhaps one day.
Proby has coded a turtle to you place it in front of a tree. It mines wood from the tree, creates a crafting bench, and then goes and creates another turtle and programs it with its commands.
Yeah.
And places it in front of another tree.
I've seen a few of these. Yeah, I had
repeats that again.
I managed to do it myself as well. Yeah, an infinite turtle system. Yeah, it's pretty good.
You'd be able to make turtle armies too.
It's been done. There was a Skynet project, from my understanding, that was being done. I didn't see how it went, but that was much about trying to destroy everything. But just eat your way through it, which is pretty cool.
Is there a sort of game where people write their little pieces of code, load them onto a computer, and they chase each other around trying to wipe out each other's code?
Yeah, there are a few. The first one I knew about was called a Mega, which is where you would program like separate cyber tanks. You'd kit them out with your own gear, and then you'd give them. You typed it in BASIC. And then they would sort of, have to try to destroy each other using the smartest algorithm, which was difficult and not much fun. And there's a few ones like Code Wars, and I think called Red Wire or something. I think
Red Wire is the one I'm thinking.
Yeah, there's a few of those that exist, but they're they're a bit elite and they're sort of a bit strange. I wanted to try and make something a little bit more approachable and a bit more silly.
Yeah.
So I went bombing
Red Wire would be much better if it had animations that shared the characteristics of the things that people name their programs. So rabbits and things like that.
That'd be a nice feature, yeah. But I find this a bit dry, so
It would just be much better with animation.
Try to make something a little bit more interesting, and that was my eventual sort of result, I'd say.
Yeah, it's pretty cool.
Yeah. So hopefully I didn't waste too much of your time. Thanks for having me. It's good fun.
Not waste of time.